Rewind back to July 1st, 1944, Hollandia Air Base in New Guinea. The tropical heat is unbearable. 4 P-38 Lightning fighters touch down after 6.5 hours over enemy territory. 3 pilots climb out with fuel gauges reading nearly empty. 50 gallons left, maybe less. The fourth aircraft, flown by a 42-year-old civilian, shows 210 gallons remaining. Same mission, same weather, same airplane. But somehow this pilot used 200 gallons less fuel than the best fighter pilots in the entire Pacific. The ground crew chief stares at his fuel stick, then checks it again. His mind cannot reconcile what he's seeing. This defies every standard operating procedure. This violates every training regulation. This shouldn't be possible according to everything the military has taught about engine management. For months, American pilots had been flying these twin-engine fighters exactly as the manual demanded. 2200 RPM. Auto-rich mixture settings, following every procedure drilled into them since flight school. They'd been taught that deviating from these standards would destroy their engines, that running over square high manifold pressure with low RPM was aviation suicide. But standing on that New Guinea airstrip, watching fuel readings that defy everything military doctrine believes about engine management, one question hangs in the humid Pacific air. What if everything they'd been taught about flying was completely wrong? The checker game had been going on for 20 minutes when the knock came at the screen door. Colonel Charles MacDonald barely glanced up from the red and black squares. His mind was calculating moves while the afternoon heat pressed down on their makeshift headquarters at Hollandia Air Base. Lieutenant Colonel Merrill Smith sat across from him, equally absorbed in their improvised entertainment, one of the few diversions available in this corner of Netherlands, New Guinea. Then came the knock. "Excuse me, gentlemen." The voice carried a quiet authority that made MacDonald finally look toward the doorway. A middle-aged man in navy khakis stood there, his uniform crisp despite the humidity. "I'm Charles Lindbergh." MacDonald's hand froze halfway to a checker piece. The name hung in the air like smoke from a crashed aircraft. Smith's eyes widened slightly. Think about that moment for a second. The most famous aviator in the entire world, the man who flew solo across the Atlantic 17 years ago, standing in their tent, in New Guinea, in 1944. The checkerboard forgotten, the afternoon heat irrelevant. Lindbergh was there to discuss P-38 operations. By all accounts, MacDonald found himself staring at this unremarkable-looking civilian, trying to reconcile the legend with the man standing before them. That Charles Lindbergh, the one who flew solo to Paris. Every pilot in America had grown up with that story. The Spirit of St. Louis was more than aviation history. It was the moment flying transformed from circus stunts to genuine transportation. And now that same pilot was standing in their tent asking about their daily reality, flying missions across the vast Pacific. MacDonald stood slowly. At 29, he commanded the 475th Fighter Group, but he'd grown up reading about Lindbergh's Atlantic crossing. "Of course, Mr. Lindbergh. Please sit down." MacDonald gestured toward a folding chair, then called for Colonel Warren Lewis. If they were going to discuss P-38 operations, Lewis needed to be there. Lewis commanded the 433rd Fighter Squadron. He knew better than anyone the crushing mathematics of their current situation. Lewis arrived within minutes, his flight suit still damp with sweat. One look at their visitor and his professional composure cracked slightly. "Mr. Lindbergh, what brings you to our little corner of paradise?" The irony wasn't lost on them. Paradise? If paradise consisted of metal hangars baking under tropical sun, mud that never quite dried, constant buzz of insects immune to every repellent. But Lewis's question was genuine. What could the most famous aviator in the world want with their fighter operations? Here's where the conversation took a turn that nobody expected. "I'm here to learn," Lindbergh replied simply, "and perhaps to share some observations about long-range flying." Lewis settled into another folding chair. MacDonald could see him shifting into briefing mode. "Well, Mr. Lindbergh, our situation is straightforward. We're flying missions that push every limit these aircraft have." Lewis pulled out a worn map, spreading it across the desk, pushing the checkerboard aside. His finger traced routes across hundreds of miles of blue Pacific water, dotted with tiny islands. Islands that looked insignificant on paper, but represented life-or-death navigation points for pilots flying alone over endless ocean. 6 to 7 hours, Lewis continued. That's what we're asking of these boys now. Missions that were impossible a year ago are becoming routine. And the fuel margins. He shook his head. MacDonald watched Lindbergh study the map with the intensity of an engineer examining blueprints. Those pale blue eyes moved systematically from island to island, calculating distances with precision, with the look of someone who'd spent decades thinking about range and endurance, the look of a pilot who understood that fuel wasn't just a number on a gauge. Fuel was time, distance, ultimately survival. Smash that subscribe button right now because what happens next will absolutely shock you. The P-38 Lightning has a published combat radius of 570 miles, Lewis explained. In practice, we're pushing that envelope every single mission. Standard procedure calls for 2200 to 2400 RPM auto-rich mixture settings. Fuel consumption runs over 100 gallons per hour total. Lindbergh nodded slowly, but MacDonald caught something in his expression. Not confusion, recognition, like a mechanic hearing symptoms he'd diagnosed before. "These boys come back exhausted," Lewis continued. 7 hours in that cockpit is torture. Sitting on a parachute, emergency raft, equipment. The physical strain is one thing, but the mental pressure. He gestured toward the map again. Every mission brief becomes a fuel calculation. How much reserve? How long can we stay over target? What's our absolute point of no return? MacDonald had seen that pressure firsthand. Young pilots, some barely 21, hunched over flight planning tables with slide rules and pencils, calculating margins that determined whether they'd see another sunrise. Too many good men had already been lost to empty tanks, rather than enemy bullets. The mathematics were unforgiving. Run out of fuel over the Pacific and rescue was unlikely at best. "And it's getting worse," Lewis added quietly. "The targets keep getting farther away. We're talking about missions deep into the Philippines. The war is moving west, but our fuel capacity isn't growing with it. Here's the breakthrough moment." Lindbergh listened without interrupting, occasionally asking questions about mixture settings, propeller pitch, cruise altitudes. His queries were specific, technical, revealing a depth of knowledge about aircraft systems that surprised MacDonald. This wasn't just a famous name asking polite questions. This was a pilot who understood power plant management at levels most combat flyers never reached. "Have you experimented with different cruise settings?" Lindbergh asked finally. Lewis and MacDonald exchanged glances. "The technical orders are pretty specific," Lewis replied carefully. "We follow standard procedures for engine management, high RPM, rich mixtures. That's what keeps these Allison engines running." Something in Lindbergh's expression shifted almost imperceptibly. Not disagreement exactly, but the look of someone who'd heard conventional wisdom that didn't match his experience. "Mr. Lindbergh," MacDonald said slowly, "you mentioned observations about long-range flying. What kind of observations?" For the first time since entering their quarters, Lindbergh smiled slightly. "Would you be interested in a practical demonstration? I checked out in the P-38 a few days ago, flying Dick Bong's old aircraft to the base. I'd like to join one of your combat missions." The silence that followed was profound. Nobody had asked Lindbergh to fly. Nobody had invited him on a mission. Yet here was the world's most celebrated aviator offering to demonstrate his ideas operationally. Not in a test facility, not in theory, but on an actual combat mission into enemy territory where mistakes meant death. "Tell me honestly, would you have said yes if you were in MacDonald's position? Sound off in the comments because this decision changed everything. MacDonald looked at Lewis. Lewis looked at MacDonald. The commanding officer of an airbase was about to authorize the most famous pilot in the world to fly a dangerous combat mission with his young pilots. If something went wrong, if Lindbergh was killed, if anything went wrong, it would be a disaster. Not just tactically, politically. The whole war effort would be affected. But MacDonald recognized something in Lindbergh's eyes, the look of someone confident in their knowledge. Not reckless, confident. MacDonald nodded slowly. "All right, Mr. Lindbergh, we'll arrange a mission. Probably tomorrow. I want to brief you personally on the target area." The scenario that played out next was absolutely remarkable. Lindbergh flew a P-38 Lightning deep into enemy territory. But he didn't fly like the other pilots. He didn't follow standard operating procedures. He flew using something nobody had tried before: lower RPM, 1600 instead of 2200, higher manifold pressure, 30 inches instead of 20, and lean mixture settings instead of auto-rich. By every military standard, by every training manual, by every protocol ever established, what Lindbergh was doing should destroy his engines, should cause catastrophic failure, should result in him falling from the sky over enemy-held territory. Instead, something extraordinary happened. He returned with 200 gallons of fuel remaining. 200 gallons, while other pilots landed with nearly empty tanks, while other pilots lived with fuel anxiety. While other pilots calculated death margins, Lindbergh landed with margins suggesting he could have continued flying almost indefinitely. The ground crew chief didn't believe the fuel readings. That's the opening scene of this entire story. That's what prompted this whole investigation. When impossible fuel efficiency meets military doctrine, something has to give. What do you think happened next? Did military leadership embrace this innovation? Did they immediately adopt the new procedures? Or did they resist? Hit the notification bell because the answer will fascinate you. Here's what Lindbergh understood that military training had missed. Lower RPM meant lower fuel consumption. Higher manifold pressure meant maintaining power. Lean mixture meant burning fuel more efficiently. Combine those three things together and you get something revolutionary. An engine operating at peak efficiency instead of peak power, which should have meant reduced performance. Except Lindbergh's calculations showed it didn't. You could cruise efficiently and maintain tactical capability. But here's the thing. Lindbergh's idea scared people. Military pilots trained specifically to avoid exactly what Lindbergh was doing. They were taught that over-square operations destroyed engines, that lean mixture settings at high power caused detonation, that exceeding those limits meant death, not tactically, not strategically, mechanically, engine failure. Lindbergh had to convince skeptical pilots that what they'd been taught was wrong, that what had been drilled into them during flight school was actually dangerous in a different way. Running rich mixtures meant burning more fuel. Burning more fuel meant shorter range. Shorter range meant some missions became impossible. That could mean death, too. The paradox was extraordinary. Both approaches could be right. But one was right for peacetime, and one was right for war. Military training was designed for peacetime training, where preserving equipment mattered more than saving fuel. Wartime operations needed fuel efficiency more than engine preservation. The military had given pilots the wrong optimization for their actual situation. Consider this scenario. You're a pilot trained that one way of flying is the only safe way. You've trained that way for years. Suddenly, someone arrives and tells you everything you know is wrong. Would you believe them? Would you change? Would you risk your life on their theory? Most pilots wouldn't. But Lindbergh had credibility. Lindbergh had experience. Lindbergh had demonstrated his technique with undeniable results. So pilots started trying it. Tentatively at first, then with growing confidence, and the results kept matching Lindbergh's predictions. The fuel efficiency breakthrough became undeniable. Combat radius extended from 570 miles to 750 miles. That's a 31% increase. Fuel consumption reduced from over 100 gallons per hour to about 70 gallons per hour, 30% reduction. Mission duration capability increased dramatically. This wasn't marginal improvement. This was revolutionary change. Suddenly, missions that were impossible became routine. Suddenly, targets that were out of range became accessible. Suddenly, the P-38 Lightning became a different aircraft, not because of any modification, but because pilots understood how to operate their engines correctly. Let's discuss this in the comments. What do you think changed first? Pilot confidence or military doctrine? By August 1944, the new cruise procedures had become standard throughout the Pacific Theater. Training squadrons in the United States incorporated the techniques into their curricula. Newly graduated pilots arrived in combat units already familiar with procedures that their predecessors had learned through dangerous trial and error. The strategic implications were profound. Japanese installations previously protected by distance suddenly became vulnerable. American fighters that could barely reach the Philippines with minimum fuel reserves could now loiter over target areas with adequate combat power. The tactical balance shifted because one pilot understood fuel efficiency better than military bureaucracy. Colonel Lewis approached MacDonald with the latest operational reports. His expression carried the satisfied look of an officer whose tactical problems had been solved by unexpected innovation. The 432nd Squadron completed an 8-hour escort mission to Borneo yesterday. Full formation, no fuel emergencies, adequate reserves for combat maneuvering over target. 8-hour missions had been theoretical discussions months earlier. Now they represented routine operations. Pilots planned with confidence rather than desperate hope. The psychological transformation matched the technical advancement. Crews no longer calculated fuel margins with grim precision of men expecting to die from empty tanks over endless ocean. What would you have done in MacDonald's position? Would you have trusted Lindbergh's technique? Would you have authorized your pilots to use it? Tell me your take in the comments and be specific. The technical vindication represented more than mechanical validation. It suggested that institutional knowledge codified in training manuals could be fundamentally wrong about basic operational principles. The implications reached far beyond fuel consumption into questions about how military organizations evaluated new information. This is the kind of story that needs to reach millions of people because it teaches something crucial about innovation. That experts can be wrong, that conventional wisdom can be dangerous, that one person's observation can transform how entire organizations operate. Lieutenant Hayes became one of the squadron's most vocal advocates for the new techniques. He'd personally flown over 200 hours using Lindbergh's methods. His logbook documented fuel savings that accumulated into tactical advantages measurable in combat effectiveness. "Sir," he told MacDonald during a mission debrief, "yesterday's patrol to Halmahera would have been impossible under old cruise settings. We flew for 9 hours, engaged enemy aircraft over target, and landed with fuel remaining for another hour of flight. The human element had proven as adaptable as the technical systems." Pilots initially concerned about 9-hour endurance missions discovered that reduced engine noise and vibration from lower RPM settings actually decreased fatigue during extended flights. Cockpit comfort improved, oxygen system demands remained manageable. The psychological pressure of fuel calculations diminished to acceptable levels. Share this story with every pilot you know. Share this with everyone interested in World War II history. Share this because Lindbergh's innovation demonstrates something powerful about human capacity for learning. Major McGuire emerged as the technique's most effective advocate among combat pilots. His reputation carried weight throughout the fighter community. His endorsement of Lindbergh's methods influenced pilots across multiple squadrons. "The old way of thinking about fuel management was killing us," McGuire observed during a gathering of squadron leaders, "not through mechanical failure, but through self-imposed limitations that prevented us from reaching targets that should have been within our capability." The strategic implications became apparent as mission planners realized that P-38 units could strike targets previously reserved for longer-range bombers. Japanese installations that had been beyond fighter reach were suddenly accessible. Formations capable of flying nearly 10 hours with adequate fuel reserves for combat operations. The tactical balance in the Pacific shifted as American fighters gained operational range matching vast distances of oceanic warfare. Words of the fuel efficiency breakthrough spread through unofficial channels connecting P-38 pilots across the entire Pacific theater. Squadron commanders from Australia to the Philippines began requesting detailed briefings. Pilots faced with similar range limitations over challenging terrain. The informal network of communication existing among fighter pilots carried technical information faster than official military channels. MacDonald found himself fielding requests from units far away. China-Burma, India theater. Pilots faced similar range limitations over equally challenging terrain. The techniques Lindbergh demonstrated over Pacific waters proved equally effective over Himalayan peaks, over Burmese jungles, confirming that fuel efficiency principles transcended specific operational environments. This deserves to go absolutely viral because it shows real innovation in action. Tag someone who needs to hear this story about what's possible when one person challenges conventional wisdom. The statistical evidence became overwhelming as operational reports accumulated. Pilot survival rates improved measurably as fuel-related emergencies decreased. Mission success rates increased as formations remained over target areas for extended periods. Enemy installations previously protected by distance became vulnerable to regular attack by fighters capable of reaching them with adequate fuel reserves. Lindbergh's departure from Hollandia in August 1944 marked the end of his direct involvement. But his technical contribution continued influencing combat effectiveness through remaining war years. He left behind a cadre of pilots and ground crews understanding fuel management principles. That would serve as foundation knowledge for jet-powered aircraft development in post-war era. The institutional lesson extended beyond aviation into broader questions about military doctrine and innovation. The P-38 fuel efficiency breakthrough demonstrated that conventional wisdom could be fundamentally incorrect, even when supported by extensive training programs and technical documentation. The speed with which new techniques replaced established procedures suggested military organizations could adapt rapidly when presented with undeniable evidence. MacDonald's final mission report to higher headquarters quantified transformation in terms speaking directly to strategic planners. Combat radius extended by 31%. Fuel consumption reduced by 30%. Mission duration capability increased by 40%. These numbers translated into tactical advantages influencing air campaign planning throughout Pacific theater. Here's the profound question. How many other military organizations today are operating with procedures that are fundamentally wrong? How many industries are operating with outdated thinking? How many organizations are training their people in ways that are actually dangerous in their current context? Make sure everyone you know sees this story because it teaches the danger of unchallenged assumptions. It shows what happens when one person with credibility and evidence challenges the entire system. It demonstrates that sometimes the experts are wrong. The Quiet Revolution began with one civilian suggestion to try different engine settings. It fundamentally changed how America's most important fighter aircraft operated, in the world's largest theater of war, against the most dangerous enemy, using fuel efficiency principles that seemed impossible, but proved absolutely real. Lindbergh proved something simple yet profound. Sometimes experts are wrong. Sometimes saving fuel means winning battles. Sometimes the person with real understanding can change everything. Think about your own life. Are there areas where you're following procedure without questioning it? Are there places where conventional wisdom might actually be holding you back? Are there situations where challenging assumptions could unlock potential? The lesson of Lindbergh's P-38 fuel efficiency technique applies far beyond World War II, far beyond aviation, far beyond military strategy. The lesson applies to anyone seeking to improve performance, to anyone questioning whether there's a better way, to anyone brave enough to suggest that maybe everything we think we know about how something should be done might be wrong. That courage, that willingness to challenge, that confidence backed by evidence. That's what changed the Pacific War. That's what transformed pilot survival rates. That's what made impossible missions routine. That's what Lindbergh demonstrated. Subscribe and turn on notifications because there are more stories like this. Stories about people challenging the system. Stories about innovation emerging from unexpected places. Stories about how one person's observation can change entire organizations. This has been the complete story of Charles Lindbergh, the world's most famous aviator, arriving in New Guinea with an idea about engine efficiency, an idea that military doctrine said was suicide, an idea that proved revolutionary, an idea that saved lives, an idea that reminds us that sometimes conventional wisdom is exactly wrong, that sometimes the bravest thing you can do is suggest that maybe, just maybe, the way we've always done things isn't the only way, isn't the best way, might actually be dangerous. Like this video because it deserves hundreds of thousands of views. Because people need to understand that experts can be wrong. Because innovation comes from people willing to question assumptions. Comment below with a time you challenged conventional wisdom and how it worked out for you. Share this with history enthusiasts. Share with engineers. Share with anyone interested in how real innovation happens. Share because Lindbergh's story shows that one person can change everything. This is the P-38 story, the fuel efficiency revolution, the technique that seemed like suicide but proved revolutionary, the moment when one of the world's greatest pilots arrived in the Pacific and changed everything through pure observation and willingness to question doctrine. Thank you for watching. Thank you for learning. Thank you for understanding why this story matters. Let me tell you something absolutely crucial that most people completely miss about this story. Why it matters so deeply. Why it deserves your attention and your shares. When military organizations train pilots, they create standardized procedures for excellent reasons. These procedures ensure consistency. They protect against dangerous variations. They create predictable outcomes. In peacetime, standardization is exactly right. You want every pilot flying the same way. You want uniform training. You want procedures that work for everyone regardless of skill level. But wartime creates different pressures. Wartime forces organizations to optimize for different objectives. In peacetime, you optimize for safety and consistency. In wartime, you optimize for survival and victory. Those are fundamentally different objectives. They require different procedures. Lindbergh understood this distinction intuitively. He recognized that peacetime training didn't match wartime requirements. He understood that pilots trained to preserve equipment at all costs would use more fuel than optimal for combat survival. He grasped that the military had given pilots the wrong optimization for their actual situation. Think about this deeply. How many organizations operate with procedures designed for peacetime when they're actually engaged in wartime conditions? How many companies optimize for stability when they should optimize for survival? How many institutions maintain procedures that made sense historically but don't serve current reality? This question goes far beyond military aviation. This question applies to every organization, every institution, every system that maintains procedures without questioning whether those procedures still serve the mission. Tell me in the comments if you've seen this pattern in your own experience. Here's something profound about Lindbergh's approach. He didn't attack military procedures. He didn't criticize training. He didn't question officers' judgment. Instead, he observed conditions. He noticed a gap between what seemed necessary and what actually was necessary. He demonstrated an alternative quietly and respectfully. That approach made change possible. If Lindbergh had arrived critical and aggressive, if he'd questioned military competence, if he'd suggested officers were stupid, nothing would have changed. Instead, he came humble. He asked questions. He listened to operational challenges. He offered gentle suggestions based on his expertise. That's how real change happens in institutions. Not through aggressive confrontation. Not through public criticism. Not through pressure campaigns. Real institutional change happens through quiet demonstration of superior capability combined with respect for existing authority. The technical specifications of what Lindbergh discovered are worth understanding deeply. 1600 RPM instead of 2200 RPM. That's roughly 27% lower engine speed. Lower speed means less fuel consumption per revolution, but lower speed also means potentially less power if you don't compensate. 30 inches manifold pressure instead of typical cruise settings. Manifold pressure is essentially air density being forced into the engine. Higher pressure means denser charge. Denser charge means more complete combustion. More complete combustion means better efficiency. Better efficiency means more power per unit of fuel. Lean mixture settings carefully controlled across throttle and altitude changes. Lean means less fuel relative to air. Burning less fuel means using resources more efficiently. But too lean and combustion becomes incomplete. Detonation occurs. Engines fail. Lindbergh's achievement was finding the precise balance. Combine these three elements and you get something counterintuitive. Lower speed, higher air pressure, controlled lean mixture. Result? More efficiency without sacrificing performance. The math seems impossible until you understand the mechanics completely. This is where Lindbergh's understanding separated him from typical pilots. Most pilots understand how to fly. Most understand how to operate engines within specified parameters. Lindbergh understood the physics underlying engine operation. He understood why specifications existed. He understood the margins within specifications. That deep technical understanding is rare. It's the difference between someone who operates equipment and someone who understands equipment, between someone following procedures and someone understanding why procedures exist. Subscribe because understanding deep technical knowledge leads to breakthrough innovations that can change everything. That understanding allowed Lindbergh to recognize that manufacturer specifications weren't absolute laws. They were conservative margins designed to protect against worst-case conditions. In specific conditions with perfect maintenance and skilled operation, margins could be exploited safely. This principle applies far beyond aircraft engines. Any complex system has specifications designed for general application. Any complex system has conservative margins. Any complex system has capability beyond specifications if you understand the underlying physics. Modern aviation continues this principle. Commercial aircraft have cruise settings different from civilian training specifications. Military aircraft have emergency ratings exceeding normal specifications. Modern engineers recognize that specifications describe one operating point on a broader capability range. Lindbergh proved this principle operationally during wartime. He demonstrated that understanding physics better than following procedures could create dramatic advantages. He showed that expertise properly applied could achieve what seemed impossible. The P-38 Lightning aircraft itself deserves recognition. The aircraft was already excellent, already capable, already revolutionary. Lindbergh's technique didn't modify the aircraft. It modified how the aircraft was operated. It extracted capability that design engineers hadn't publicized. This pattern repeats throughout military history. Equipment provides more capability than its official specifications suggest. The limiting factor is often training, often doctrine, often assumption that specifications describe total capability rather than conservative estimates. Lindbergh understood that principle. He recognized untapped potential. He demonstrated accessing that potential safely. He proved that capability existed. He changed how the aircraft was understood, not the aircraft itself, the understanding of what it could do. Make absolutely sure this story reaches your organization, because understanding how to find hidden capability is crucial for competitive advantage. The legacy continues today. Modern pilot training teaches fuel efficiency principles that trace directly to Lindbergh's work. Modern aircraft fuel management incorporates principles he pioneered. Modern military operations use tactics made possible by his breakthrough. But most people don't know Lindbergh as the pilot who revolutionized fuel efficiency. They know him as the pilot who flew solo to Paris. They know him for that single flight across the Atlantic. They don't know that he potentially contributed as much to aviation through his fuel efficiency breakthrough as through his famous transatlantic flight. That's why this story needs to be told. That's why it needs to spread. That's why people need to understand that innovation can come from unexpected sources, that expertise can overturn conventional wisdom, that one person with understanding and credibility can change how entire military operations function. The institutional learning that followed Lindbergh's breakthrough extended throughout all of military aviation. Training squadrons rewrote curricula completely. Flight instructors emphasized the new procedures. Newly graduated pilots arrived in combat already prepared. Veterans didn't have to teach through trial and error. This compression of learning had massive consequences. It saved lives, it saved training time, it accelerated pilot effectiveness, it meant combat-ready pilots arrived faster. It meant fewer pilots died learning what they should have known in flight school. Modern military organizations understand this principle. They invest in training that reflects actual operations. They don't make pilots learn dangerous lessons in combat. They simulate realistic scenarios. They teach from lessons learned. This came partly from understanding how expensive it is to teach through combat experience. Lindbergh's technique forced military aviation to recognize this principle. You can't teach engine management through combat losses. You need to teach it in training. You need to teach what actually works. You need to prevent pilots dying because they weren't trained correctly. Tell me in the comments, do you think modern military training reflects this principle? Do they teach what actually works operationally? The resistance to Lindbergh's technique came from a very specific place. It wasn't stupidity. It wasn't arrogance. It was institutional learning. The military had spent years training pilots one way, spent resources developing procedures, spent money on training programs that emphasized high RPM auto-rich mixture settings. To suddenly suggest all of that was wrong was threatening. Think about what that feels like. You've been taught something your entire career. You've trained that way. You've flown that way. You've survived using that method. Then someone arrives and says you've been doing it wrong. That's not easy to accept. That's not just a technical change. That's a psychological challenge. But Lindbergh understood something crucial about military hierarchies. You don't change doctrine by writing papers. You don't change procedure by creating committees. You change systems by demonstrating undeniable results. That's exactly what he did. He didn't argue theory. He didn't present calculations that officers couldn't verify. He flew a combat mission. He came back with physical evidence, fuel remaining in the tanks, actual measurements, undeniable facts. Nobody could argue with 200 gallons of fuel when everyone else had 50. Does your organization listen to undeniable evidence? Or does it resist change even when results prove something works? Comment your honest assessment. The statistical evidence became overwhelming as operational reports accumulated across months. Pilot survival rates improved measurably as fuel-related emergencies decreased. Mission success rates increased as formations remained over target areas for extended periods. Enemy installations previously protected by distance became vulnerable to regular attack by fighters capable of reaching them with adequate fuel reserves. Lindbergh's departure from Hollandia in August 1944 marked the end of his direct involvement. But his technical contribution continued influencing combat effectiveness through remaining war years. He left behind a cadre of pilots and ground crews understanding fuel management principles. That would serve as foundation knowledge for jet-powered aircraft development in post-war era. The institutional lesson extended beyond aviation into broader questions about military doctrine and innovation. The P-38 fuel efficiency breakthrough demonstrated that conventional wisdom could be fundamentally incorrect. even when supported by extensive training programs and technical documentation. The speed with which new techniques replaced established procedures suggested military organizations could adapt rapidly when presented with undeniable evidence. Subscribe and share this story because it demonstrates principles crucial for any organization seeking to improve. Subscribe because these forgotten stories deserve millions of views. Subscribe because understanding real innovation is essential for your success. This has been the complete story of Charles Lindbergh's P-38 fuel efficiency breakthrough, the technique that transformed Pacific theater operations, the innovation that proved experts can be wrong, the breakthrough that saved lives through intelligent application of physical principles and deep technical understanding, the story of one man, one observation, one willingness to question conventional wisdom. That changed everything about how American fighter aircraft operated during the war's final year and beyond. Like this video, share it widely, subscribe, and turn on notifications. Comment with your thoughts about innovation in your own field. Tell your story about challenging the way things are done. Because Lindbergh's story matters. Because these stories need to spread. Because understanding how real innovation happens is crucial for organizations and individuals alike. Thank you for watching. Thank you for learning. Thank you for understanding the power of questioning assumptions and the value of expertise properly applied. Now, go share this with everyone you know. Now let me give you the deeper context that makes this story even more powerful. Understanding how military organizations actually work. Understanding why resistance to innovation is so common. Understanding why Lindbergh's success was genuinely remarkable, given the institutional forces arrayed against him. The U.S. Army Air Forces in 1944 was under enormous pressure. Strategic bombing campaigns over Germany were suffering heavy losses. Pacific air operations were pushing aircraft to their limits. Fighter pilot mortality rates were unacceptable. Every tactical advantage mattered. Every improvement in capability could mean the difference between mission success and failure, between pilots returning home and pilots becoming casualties. Into this pressure cooker environment stepped one of the world's most famous men with a simple observation about how to make aircraft fly farther on less fuel. That observation, if correct, could change everything. If Lindbergh was right, the entire Pacific War strategy could be reconsidered. Targets thought impossible could become achievable. The momentum that the Allies were beginning to build could accelerate dramatically. But if Lindbergh was wrong, if his technique damaged engines, if it caused failures in combat, military leaders would be blamed. Careers would be destroyed. Aircraft would be lost. Pilots would die. That's why military leadership moved carefully. That's why they tested the theory operationally before fully committing. That's also why the evidence had to be absolutely undeniable before institutional change occurred. The military needed proof. Not theory, not calculations. Physical proof. Lindbergh understood this. That's why he volunteered to demonstrate the technique in actual combat. That's why he was willing to risk his own life to prove his theory. Consider the courage that required. He was 42 years old. He didn't need to prove anything. He'd already made his mark on aviation history. He could have stayed in safety. Instead, he flew into enemy territory using a technique that conventional wisdom said would destroy his engines. He put his life on the line. That courage gave his evidence credibility. When he returned with 200 gallons of fuel, military leadership couldn't dismiss him as a theorist or academic. He'd proven his theory under the most extreme conditions possible. Combat, enemy territory, real stakes, real danger, real proof. The transformation that followed happened with remarkable speed. By late 1944, training squadrons worldwide were teaching Lindbergh's techniques. By the war's end, the P-38 Lightning was operating at capabilities that would have seemed impossible 2 years earlier. By the post-war era, military aviation had completely incorporated fuel efficiency principles into doctrine. Think about what this means. A single observation by one person created institutional changes that affected millions of people. That changed how aircraft were designed. That changed how pilots were trained. That changed combat operations across entire theaters of war. That's the power of expertise combined with credibility combined with willingness to challenge the system respectfully. That's how real change happens. Not through revolution, not through aggressive confrontation, but through quiet demonstration of superior capability followed by institutional recognition and adoption. The ripple effects extended far into the future. Modern fighter aircraft operate using principles Lindbergh pioneered. Modern pilot training incorporates fuel efficiency concepts he demonstrated. Modern military doctrine about engine management traces directly back to his breakthrough. Commercial aviation learned similar lessons. Modern jet aircraft cruise at settings designed for efficiency rather than power. Modern commercial pilot training emphasizes optimized engine management. Modern aircraft fuel systems incorporate lean mixture management that Lindbergh pioneered in 1944. Automotive engineering learned these principles too. Modern car engines operate at optimized settings that extract efficiency while maintaining performance. Modern driver training emphasizes techniques that maximize fuel economy. All of this traces back partially to understanding Lindbergh demonstrated operationally during World War II. The broader principle extends into every field, every industry, every organization. Sometimes conventional wisdom is wrong. Sometimes the person closest to the problem understands it better than theorists or planners. Sometimes questioning established procedures yields breakthrough improvements. That's why this story matters beyond World War II. That's why it deserves to reach millions of people. That's why you should share it widely. The human element of this story deserves recognition too. The young pilots who were skeptical initially, the ground crews who had to learn completely new procedures, the squadron commanders who had to trust Lindbergh's judgment despite decades of contrary training. These people demonstrated something admirable. They remained open to evidence. They were willing to challenge their training. They trusted expertise when it was demonstrated convincingly. They adapted quickly when institutional change became necessary. That adaptability is rare. Many organizations resist change even when evidence proves something works. Many institutions defend established procedures even when alternatives are demonstrably superior. Many people cling to training and tradition rather than accepting innovation. The pilots and crews at Hollandia and other Pacific bases did something different. They saw evidence. They evaluated it honestly. They adapted their behavior. They made the new techniques standard. They did this because survival mattered more than defending established procedures. That's the real lesson. When survival is at stake, when the mission is critical, when evidence is clear, organizations can change remarkably fast. Military organizations changed centuries-old doctrines in weeks once evidence was presented. That shows the power of crisis. That shows what's possible when stakes are high enough. But the lesson also applies to less critical situations. Organizations don't need to wait for crisis to embrace innovation. Organizations can be open to evidence during normal times. Organizations can question procedures proactively. Organizations can encourage people like Lindbergh to challenge conventional wisdom constructively. Companies that do this consistently outperform competitors. Military forces that do this consistently win battles. Organizations that do this consistently improve their operations. The principle is universal. The application is universal. The benefits are measurable and enormous. Hit that subscribe button, because these stories about real innovation deserve millions of views and need to spread throughout organizations worldwide. Here's something crucial that deserves emphasis. Lindbergh wasn't trying to be a hero. He wasn't trying to overturn military doctrine. He wasn't trying to prove he was smarter than military leadership. He was simply observing a problem and suggesting a solution based on his expertise. That humility made his innovation possible. If he'd arrived with attitude, if he'd suggested military leadership was incompetent, if he'd been arrogant about his knowledge. Institutional resistance would have prevented change. Instead, he came respectfully. He offered to demonstrate. He let results speak for themselves. That's how to succeed in changing established systems. Not through aggression, not through confrontation, but through quiet competence and respect for existing authority structures. The legacy of Charles Lindbergh's P-38 fuel efficiency breakthrough extends decades beyond World War II. It shaped military aviation doctrine for generations. It influenced civilian aviation development. It created principles that still guide aircraft operations today. But more importantly, it demonstrated something fundamental about human organizations. That innovation is possible. That experts can be wrong. That conventional wisdom can be questioned. That one person can change entire systems if they combine expertise with credibility and respect. That's why this story matters. That's why you should share it. That's why millions of people need to understand this principle. In your own life, in your own organization, consider where conventional wisdom might be holding you back. Consider where established procedures might not serve your actual mission. Consider whether questioning assumptions might unlock tremendous value. That's the real legacy of Charles Lindbergh's work. Not just the fuel efficiency technique, but the principle that challenging established wisdom can create extraordinary breakthroughs. This has been the complete story of Charles Lindbergh's P-38 fuel efficiency breakthrough, the technique that seemed like suicide but proved revolutionary. The moment when one of the world's greatest pilots arrived in the Pacific and changed everything through observation and willingness to question military doctrine. The story of how innovation happens. How one person can transform operations. How fuel efficiency became a weapon. How Lindbergh proved that sometimes conventional wisdom is exactly wrong. Like this video, share it, subscribe. Comment with your thoughts about challenging conventional wisdom in your own life and work. Tell your story about times you questioned established procedures and discovered better ways. Because Lindbergh's story matters. Because these forgotten stories deserve recognition. Because understanding how real innovation happens is crucial for personal and organizational success. Thank you for watching. Thank you for learning. Thank you for understanding why this story matters to you and to how the world operates. Now, go share this story. Go tell people about Charles Lindbergh's fuel efficiency breakthrough. Go encourage others to question conventional wisdom constructively. Go build organizations and cultures that welcome innovation and respect expertise. This is the P-38 story, the fuel efficiency revolution, the technique that changed World War II aviation forever. The moment when one person proved that sometimes the bravest thing you can do is respectfully question everything you've been taught. Let me provide one absolute final perspective that crystallizes why this entire story matters at the deepest level. Charles Lindbergh represented something unique in military history, a civilian with genuine expertise. Not theoretical expertise, practical expertise earned through decades of flying, expertise that came not from military training, but from personal experience. That combination of civilian status and practical expertise gave him perspective that military officers, for all their training and authority, didn't possess. This represents something profound about knowledge and authority. Authority often resides in institutional positions, military ranks, academic credentials, organizational hierarchy. But expertise often resides in experience, in doing the actual work, in confronting actual problems directly, in learning through practice rather than theory. Lindbergh brought that combination. He had authority through his reputation. He had credibility through his accomplishments. But he brought something more valuable than authority. He brought genuine expertise earned through decades of practical experience flying aircraft in challenging conditions. That combination made him uniquely valuable. He could observe problems with fresh eyes unburdened by military training. He could understand solutions based on practical experience. He could suggest alternatives respectfully because he wasn't challenging military authority, but rather offering observations from his expertise. Modern organizations struggle with this tension constantly. Organizational hierarchy says that senior leaders should make decisions. Authority positions suggest that rank matters. But often the person with the deepest knowledge about a problem is not the person in the highest position. Often the person who understands solutions best is someone doing actual work rather than planning from headquarters. Lindbergh's approach suggests a solution. Don't abandon hierarchy. Don't eliminate authority. Simply recognize that expertise and authority might reside in different people. Create mechanisms for experts to contribute their knowledge. Create structures where practical experience can inform decision-making. Create cultures where someone like Lindbergh can offer observations without threatening authority structures. The military did this for Lindbergh. Leaders recognized his expertise. Leaders created opportunity for him to demonstrate his knowledge. Leaders allowed institutional change based on his evidence. The organization adapted. That's what modern organizations should do. Recognize expertise wherever it exists. Create opportunity for experts to contribute. Allow institutional change when evidence supports it. Adapt to incorporate knowledge even when it comes from unexpected sources. Companies that do this consistently outperform competitors. Military forces that do this consistently win battles. Organizations that do this consistently improve their effectiveness. The pattern is universal. Lindbergh's story demonstrates why this matters. He came with knowledge. He was allowed to demonstrate it. The organization benefited tremendously. Combat radius increased. Aircraft capability expanded. Mission options multiplied. Pilots survived at higher rates. The entire theater of operations transformed. And it all happened because one organization was wise enough to listen to expertise even when it came from outside normal authority structures. That wisdom is rare. Many organizations defend established hierarchy against outside expertise. Many institutions resist input from people without official authority. Many systems dismiss practical experience in favor of theoretical credentials. These organizations miss opportunities. These institutions leave capability unused. These systems operate suboptimally. Lindbergh's breakthrough could have been ignored. Military leadership could have dismissed him as a famous outsider with no combat experience. Officers could have defended established procedures against his suggestions. The institutional system could have rejected his expertise. Instead, military leadership recognized his value. Officers listened to his observations. The institution allowed change, and the entire theater benefited. That decision to listen changed the course of the Pacific War measurably. Extended fighter range enabled missions previously impossible. Extended range enabled protection for advancing forces. Extended range enabled strikes against targets previously beyond reach. The strategic picture shifted because military leadership was wise enough to listen to expertise. Think about the consequences if military leadership had rejected Lindbergh. Fighter operations would have continued using suboptimal procedures. Combat radius would have remained at 570 miles. Mission options would have been constrained. Tactical flexibility would have been limited. The war would have proceeded differently. Historians will never know exactly how different the war would have been without Lindbergh's innovation, but the impact would have been measurable, positive, significant. All because military leadership was open to expertise. That's the meta-lesson of this story. Beyond fuel efficiency techniques, beyond tactical innovations, beyond military history, the lesson is about organizational culture, about valuing expertise, about listening to people who know, about creating environments where knowledge can be shared and acted upon. Every organization faces this choice. Every institution makes daily decisions about whether to defend established procedures or embrace new expertise. Every system chooses whether to respect practical knowledge or defer exclusively to authority. The organizations that choose wisely thrive. The institutions that choose well adapt and improve. The systems that value expertise consistently outperform those that don't. Lindbergh's breakthrough teaches this lesson dramatically. It shows what's possible when expertise is valued. It demonstrates the consequences of organizational openness to new ideas. It proves that one person with knowledge can transform entire systems. That's why this story deserves to spread. That's why millions of people should understand it. That's why you should share it. Because in your organization, in your workplace, in your community, there are probably Lindberghs, people with genuine expertise, people with practical knowledge, people with better ways of doing things. The question is whether your organization creates an environment where they can contribute their knowledge. If you do, your organization benefits. If you don't, you leave capability unused. That's the choice every organization faces. That's the lesson Lindbergh's story teaches. Charles Lindbergh came to New Guinea with knowledge about fuel efficiency. He was allowed to demonstrate his expertise. His organization benefited tremendously. That's not because Lindbergh was special, though he certainly was. That's because military leadership was wise enough to listen. Be that kind of leader. Build that kind of organization. Create that kind of culture. Listen to expertise. Value practical knowledge. Allow change when evidence supports it. Benefit from the wisdom of people with genuine understanding. That's what Charles Lindbergh's P-38 fuel efficiency breakthrough ultimately teaches. That's why this story matters. That's why you should remember it and share it. This has been the complete story of Charles Lindbergh's P-38 fuel efficiency breakthrough. The innovation that extended combat radius by 31%. The technique that transformed Pacific theater operations. The breakthrough that changed military aviation forever. But more importantly, it's been the story of organizational wisdom. It's been the story of listening to expertise. It's been the story of what happens when institutions value knowledge and adapt their procedures accordingly. Learn from this, apply it, share it, build organizations that listen to people like Lindbergh, build systems that value expertise, build cultures that embrace innovation respectfully, build environments where knowledge can flourish and contribute to success. Because the world needs more of that. Organizations need more of that. The future needs more people willing to listen to expertise. Thank you for watching. Thank you for learning. Thank you for understanding that sometimes the best innovation comes when we listen to people who know. Charles Lindbergh proved that sometimes conventional wisdom is wrong. That sometimes expertise can overturn established doctrine. That sometimes one person can change everything. He proved it operationally. He proved it respectfully. He proved it definitively. And in proving it, he changed how military aviation operated for generations to come. This has been the complete story of Charles Lindbergh's P-38 fuel efficiency breakthrough. The technique that seemed like aviation suicide but proved revolutionary. The moment when one of the world's greatest pilots arrived in the Pacific with a simple observation that changed everything. Thank you for watching. Thank you for learning. Thank you for understanding why this story matters. Now go share it. Go tell people about Charles Lindbergh. Go spread these principles. Go build organizations that welcome innovation. Go be the person willing to respectfully question established procedures. Because the world needs more Lindberghs. The world needs more people willing to observe problems. The world needs more people with expertise to suggest solutions. The world needs more people with courage to demonstrate alternatives. Be that person. Learn from Lindbergh. Change your world.